Welcome back to this video series on npm PowerUP. In this video we will look at how to export PMIC settings from npm PowerUP and add them to any existing Zephyr RTOS firmware application. For a full walkthrough of the features of npm PowerUP, have a peek at the previous video in this series. To demonstrate, we have set up two kits, a nRF52 series development kit running a basic Blinky firmware and the npm 1300 EK. The board controller for the EK is powered off, so the PMIC is connected by jumper wires to the I2C peripheral of the nRF52 DK. At this point, the PMIC settings are not implemented on the nRF52-832 on the DK, which is why the battery connected to the EK is not charging, even though the PMIC is powered by USB-C. So what we will do is we will go back into npm PowerUP and we will set all the settings. We don't even need to connect to the kit. We will set all the settings that we want to be used in our application. So we want to charge the battery back up to 4.2 volts at 800 milliamp hours because we have a quite large battery. We want buck 1 to be initialized at 2.5 volts after startup. We want the buck 2 to be initialized to 3.3 volts after startup, and this is the voltage that it will be set to after being set to the voltage determined by the R set resistors on the kit, which you also need to put into your hardware design. Other features you might want to take advantage of is, for example, let's just for the sake of it change LED 0 to charging and LED 1 to charging error. So they have different colors, so we will be able to see that actually our changes took effect. And when we're happy with the settings, we just export this configuration and we select the overlay file type and we put it into the directory of our application, like this. Then we go back into VS Code. We edit our build configuration so that this overlay is a device tree overlay in our build configuration. Then it will do a pristine build again. There are some more configurations we need to make. One of them is that we need to enable the PMIC features in the Kconfig. So I have a little cheat sheet here with the Kconfigs that I need to put in to make this sample work. So you need to enable GPIOs, enable the shell, configure logging, configuring the regulators and the sensor and the LEDs. And this pulls in all the relevant functionality from the Zephyr project that you need for the PMIC to work. And then there's one more thing we need to do, and that's that we need to configure the I2C port on our DK to have pull-up, because the EK or the DK don't feature pull-up resistors. This will suck power, so it's better to have internal pull-up on the kit. And you can do that by going into the overlay and adding these lines at the end. And then we will do a pristine build. Then we can flash this latest build to the 52DK Let's unpower the PMIC while it's flashing. Okay, the kit has finished flashing. You can see that the light has started blinking again. So let's see if we have succeeded. So let's just power back on the PMIC. We can see the sample is running, and let's now see if the battery will start charging once we connect it to power. And it does, and you can see that it's the red LED that we configured in PowerUp that lights up instead of the green LED that's normally indicates charging. So that's a success, and that's how easy it is to implement npm 1300 functionality in any previous existing nRF52 or nRF53 series firmware that you have. We did not need to touch our main C files at all. But for the base configurations, enabling charging and so on, the static functions can be enabled just by the overlays from npm PowerUp. In the next video, we will look at how you can profile your own battery to take advantage of the advanced fuel gauging capabilities of the npm 1300 PMIC.